There's rules for definite and indefinite integrals that help us simplify things and enable us to compute them. Here are some really simple ones. We have rules for indefinite integrals and very similar rules for definite integrals. One of them is if we take the sum of two functions and we want to find the indefinite or definite integral, we can split it apart and find the indefinite integral separately, or the definite integral separately. Another one is if we have a constant here, c times f of x. We can write the c out in front. Same thing with definite integral. Let's see examples of how we use these rules to compute definite and indefinite integrals. We do this all the time, and it's almost automatic after you've done a few examples, but let's go through this one step by step. So we want to integrate 3x squared plus 2x dx. This rule tells us that we can integrate 3x squared dx and add the result to 2x dx. That is, we can essentially distribute the integral sign through and integrate each of these functions separately. Now that only works because this is a plus sign. If it's a times sign, that doesn't work anymore. So don't do it. Now the 3 and the 2 are constants. So since those are constants, we can write them out in front using this rule. So we can write this as 3 times the integral of x squared dx plus 2 times the integral of x dx. Again, since that's a constant, it can come out in front. If it's not a constant, if it has an x in it, it has to stay in there. That's because we're integrating with respect to dx. So if we have a dx here, anything with an x in it has to stay inside. If it doesn't have an x in it, like it's just a constant 3, it can go out in front. Now we can apply the rules we know. The antiderivative of x squared is x cubed over 3 plus a constant. The antiderivative of x is x squared over 2 plus a constant. Potentially different constants here, c1 and c2. Now we can distribute through the 3 and just get an x cubed. We can distribute through the 2 and just get an x squared. And then we'll have 3 times c1 plus 2 times c2. But that's just one big constant. We usually just write plus c. In practice, we don't write all these intermediate steps down. We just say the antiderivative of 3x squared is, well, 3x cubed over 3, which is x cubed. The antiderivative of 2x is 2x squared over 2, which is x squared. And we just add on one constant. But these intermediate steps illustrate the fact that we're using these rules, and is a good check to make sure that we did everything right. That is, that we made sure that was a sum and that these were just constants that we were pulling out. Let's do a similar example with definite integrals this time. So here we have the integral from 2 to 4 of 2x squared minus 3x dx. Again, we can use this rule to separate it into two pieces. And since the 2 and the 3 are constant, we can pull them out in front. So here we've used both this rule and this rule together. And we see we now have these separate integrals to do, x squared and x. And so we do those. The integral of x squared is x cubed over 3. We need to evaluate that between 2 and 4. The integral of x is x squared over 2. We need to evaluate that between 2 over 4. That is, x cubed over 3 is one of the antiderivatives of x squared, and x squared over 2 is one of the antiderivatives of x. Well, we could do these separately. You could also combine them and take 2x cubed over 3 minus 3x squared over 2 and evaluate that between 2 and 4. And frequently when you were doing this problem, you would leave out these red steps again and jump straight to the green step and just say, well, this was 2 times x cubed over 3 minus 3 times x squared over 2 and evaluate between 2 and 4. These red steps are just to illustrate that these rules are what's behind this process of being able to go from here to here. And now you have to evaluate this, and so that means that you need to plug in a 4. So everywhere there's an x, you plug in a 4. This is what you get. And then you subtract. Everywhere there's an x, you plug in a 2. When you plug in a 2, this is what you get. And now you've got this big arithmetic problem. So you calculate that. Calculate, 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 calculate. And if I did it right, you get 58 over 3. That's how you use these rules to find definite and indefinite integrals. You'll use them automatically. Just make sure you use them correctly. That is, it only works if there's a plus here and that this is a constant.